Every empire must face its final chapter. Every revolution ignites with a single blinding spark. And sometimes the things that change everything are the ones no one ever sees coming. I'm Luke, and you've arrived at the grand finale of tiny inventions that changed the world. 15 epic episodes, 150 revolutionary breakthroughs, and now we bring it all to a thunderous close with a lineup destined to astonish. Let's begin. NASA developed the Space Shuttle in the 1970s to create a reusable spacecraft that could reduce the cost of space missions. Engineers designed it with airplane-like wings for controlled re-entry and solid rocket boosters for liftoff. The shuttle launches vertically using rocket boosters, orbits Earth while deploying satellites or docking with the ISS, then glides back to land on a runway like a plane, allowing its main components to be reused. After decades of planning and development by NASA and ESA, Hubble was launched to overcome atmospheric distortion that blurs Earth-based telescopes. Its designers included large mirrors and instruments capable of capturing light across multiple wavelengths. Orbiting above Earth's atmosphere, Hubble collects light with its mirrors and directs it to scientific instruments that capture detailed images and spectra, giving astronomers crystal-clear views of distant objects. So, the idea was theorized way back in the 1980s by physicists like Richard Feynman and David Deutsch, who realized that classical computers just couldn't efficiently simulate quantum phenomena. Then, research labs started building prototype quantum processors. Quantum computers use qubits, which can represent 0 and 1 simultaneously through superposition, and link them via entanglement. This allows massively parallel computations to solve specific complex problems much faster than classical computers. Inspired by human cognition, pioneers like Alan Turing and John McCarthy laid the foundations for machines that could simulate intelligent behavior. Early programs focused on logical reasoning, and over time these evolved into today's machine learning algorithms. AI systems process large datasets using algorithms to recognize patterns, make decisions, and improve from experience. This enables applications ranging from speech recognition all the way to autonomous driving. SpaceX and others set out to cut spaceflight costs by designing rockets that could safely return and land vertically after launch. A pretty huge challenge that needed innovations in propulsion, navigation, and materials. After delivering payloads to orbit, the rocket's first stage fires its engines to slow descent and uses grid fins and landing legs to guide a soft vertical landing. This makes it possible to refurbish and reuse the rocket. If you're loving this journey through humanity's greatest tech feats, make sure to hit that like button and subscribe. You don't want to miss what's coming next. Physicists Andrei Geim and Konstantin Novoselov isolated graphene by peeling single atomic layers of graphite using simple adhesive tape, a breakthrough that earned them the Nobel Prize. Graphene is a one-atom thick sheet of carbon atoms arranged in a hexagonal lattice. Its structure gives it exceptional strength, electrical conductivity, and flexibility, making it ideal for advanced electronics and materials. Inspired by Einstein's general relativity prediction, scientists built LIGO with laser interferometers to detect tiny space-time ripples caused by massive cosmic events. It took decades of development and sensitive engineering. LIGO splits laser beams down 2 long perpendicular arms. When a gravitational wave passes, it slightly changes the arm lengths, altering the interference pattern of the lasers, which signals detection. After, decades of research trying to replicate the sun's fusion process right here on Earth, scientists built experimental reactors like tokamaks and inertial confinement facilities. These were designed to confine and heat plasma to some seriously extreme temperatures. Fusion energy is, produced by forcing atomic nuclei to combine, and when that happens, it releases an enormous amount of energy. Devices like ITAR are using magnetic fields to contain hot plasma just long enough for those fusion reactions to occur, all in the hope of providing clean and abundant power for the future. The Soviet Union actually launched Sputnik, the very first artificial satellite. using ballistic missile technology to send it into orbit around Earth. That moment marked the dawn of the space age and honestly prompted rapid advances all over the world. Satellites now orbit Earth at all sorts of altitudes, carrying instruments for communication, navigation, or just observation. They relay signals, collect data, or capture images, making things like GPS and weather forecasts possible for everyone. Building on earlier battery research, John Goodenough and his colleagues developed lithium-ion batteries with high energy density and rechargeable properties, which, completely revolutionized portable electronics. Lithium ions shuttle between the battery's anode and cathode during charging and discharging, storing and releasing electrical energy efficiently for use in, well, countless devices we rely on every day. The tiniest things often leave the loudest echoes. To every click, every like, every curious mind who joined us. Thank you for joining this incredible journey through humanity's most transformative inventions. If you enjoyed this series, don't forget to like, subscribe, and share it with fellow tech lovers. Until next time, stay curious. A new journey awaits.